Good day, guys. I wanted to go ahead and give you the work on the test review so that you could look at it today in class, and I will hopefully have this posted and leave it with the substitute so that you can get to this online as well. So here is the first problem on the Trig review, on the test review. This test will be comprised of trigonometry problems as well as circle problems with sector areas and arc lengths. For the first problem, we had a triangle that was a right triangle, and it had one side that was known and one angle that was known, and we needed to find the other two sides. We couldn't use Pythagorean's theorem because of the fact that we only knew one side, so that brought us to trig. SOHCAHTOA, we did label opposite, hypotenuse, and adjacent, and we went through and said, you know what, tangent has to do with opposite and adjacent, so we isolated and wanted to find one variable. We picked x first, so x and 8 would be opposite and adjacent. That's TOA. Tangent theta equals opposite over adjacent. So the tangent of 45 in this case is equal to 8 divided by x. 8 is the opposite, x was the adjacent. We worked that out and we got 8 divided by tan 45, x was equal to 8. I then decided to go ahead and try a different method for the second one. Since I already knew this was 8 and 8 and it's a right triangle, I could use Pythagorean's theorem here to find that the y was 8 square roots of 2. Okay, so let's move on to problem number 2 now. Sorry if it's a little shaky whenever I move the paper. Now, let's take a look at this problem. We are once again in the scenario where we have a right triangle. We have one angle that we know and one side that we know. So this looks like it's going to fit for trig again. So we want to think about SOHCAHTOA. Alright, so the first thing we probably ought to do is figure out which sides are opposite, adjacent, and hypotenuse. So from the 60-degree angle, the side that's opposite would be A. The side that's a hypotenuse is always across from the 90-degree angle. So that's hypotenuse. And then the 24 would be left to be the adjacent. Using that, I can see that I'm going to need to set up, sorry if my mic's just a little scratchy there, I'm going to need to set up a ratio, a trig ratio, using one of these letters with the 24. So if I start with opposite and adjacent, I can go through that's opposite hypotenuse is sine, cosine is adjacent hypotenuse, tangent is opposite adjacent. So I'm going to use tangent because it has opposite and adjacent in it. So I'm going to set this up as tangent of theta equals opposite over adjacent. So now I'm going to put in the value for opposite, the value for adjacent, and the value for theta. So tan of 60 degrees equals opposite, which is A, over adjacent, which is 24. Probably not a good thing that I use two different A's in the same problem. Here, we'll just go ahead and write that as adjacent, and this is opposite, and settle that. So this A is the one we're looking for. So now I need to multiply both sides by 24. And I get A equals 24 tan 60 degrees. And I'm going to show you how to plug that into your calculator as soon as I can find what I did with my calculator. Here it is. Okay, so on your calculator, I want to put in 24 tan 60. So I'm going to turn it on here and type in 24 times. I'm going to hit the tangent button and put 60 inside and close the parentheses. Make sure that if you're using my calculator, you have a little D up here for degrees. If you're using one of your own calculators, you need to make sure it's also in degree mode, not radians. That's going to be 24 root 3. 24 root 3. So A is 24 roots of 3. So that leaves you the option of doing Pythagorean's theorem again. If I know that this is 24 root 3, I could use Pythagorean's theorem or I could use trig again. I'm going to go ahead and use trig. this second time. So this is hypotenuse and adjacent. I like 24 better than 24 roots of 3. So I'm going to use hypotenuse and adjacent, which is cosine. Okay, so cosine theta equals adjacent over hypotenuse. Okay, I'm going to separate here. That means that I'm looking at cosine of 60 degrees is equal to adjacent is 24, hypotenuse is b. To get the b out of the bottom, I need to multiply both sides by b. So that's going to cancel, and I'm going to move up here, and I'm going to get b cosine 60 equals 24. Now if I divide both sides by cosine 60 to get rid of that, then I'm going to get b equals 24 divided by cosine 60. Once again, I'm going to put that in my calculator, and I'm going to put this in a fraction bar so you guys can see it. So if I clear it and put the fraction button, then I can put 24 on top, cosine 60 on bottom. Oh, and notice that it says go to. I did not put a closing parentheses. There we go. It does not like that. You got to make sure you close it. So 48. B equals 48. So A was 24 roots of 3. B was 48. And there are my answers. Now at this point, you guys may decide as a class whether you want to keep going on one problem at a time or if you want to skip forward. So you may need to skip forward in the problems, and I'll try to keep the number displayed up here, and I will go through these in order as we go, because that way you can follow the problems one at a time. And I will try to work every problem that I can on this packet. Okay, so number 3. Give me just a moment. Okay, for number 3, I once again have a square. This is going to have 2 right angles. I got a 45 degree and a 12. Now something we've noticed about these 45 degrees is this is going to be 45 degrees. That means this is 45 degrees because they were marked as congruent, and this is 45 degrees. And so that tells me that these are isosceles. Isosceles triangles. Both of these triangles 1 and 2 are isosceles. If they're isosceles, then this 12 over here is the same as this 12 over here, and this 12 over here, and this 12 over here. We already found y. Now all we need to do is find x. I could use trig, or I could use SOHCAHTOA. Okay? Or, sorry, my bad, those are the same thing. Trig or Pythagorean's theorem. It's up to you. So I could do 12 squared plus 12 squared equals x squared for Pythagorean's theorem on this triangle right here. And I'm going to get 144 plus 144 equals x squared. 288 equals x squared. X equals the square root of 288. Now normally we do have to consider that there's a positive and negative square root, but since this is distance, we don't deal with negative distances, so we don't have to worry about the negative side of that. So this is going to be x equals the square root of 144 times 2, because that's what 288 is. And I know the square root of 144, well, I just found it. It was 12. So x equals 12 roots of 2. Okay, I could also use trig to do this, and I could set up any ratio that I wanted that involved x. So if I set up sine of 45 equals opposite from 45 is 12, so 12 over x. Cross multiplying, I'm going to get and if I plug that in, I will get 12 square roots of 2. Okay, moving on to number 4. On number 4, we once again have 2 right triangles. This is a 30-degree angle. This side is 14, and I want to find N and M, so this would be a chance to put your SOHCAHTOA to work. Let's see, that makes this 60 degrees, and this is also going to be 60 degrees because of the congruency marks, and that marks this as 30 degrees. I don't necessarily know that those are that you have to get those right now, but let's use the 30 degrees as our theta. And so setting up SOHCAHTOA again, SOHCAHTOA, we're going to get that 30 is our theta, and 14, I'm going to go ahead and label this, is opposite, M is adjacent, and N is hypotenuse. Okay, and so now if I want to take a look at these, 30, I want to deal with opposite and hypotenuse, that's so. So sine theta equals opposite over hypotenuse, and so sine of, in this case, it's 30 degrees we're looking at. 30 degrees equals opposite. Opposite 30 was 14. Hypotenuse was N. Okay, setting up my proportions, we've learned a little fancy trick that these two right here can pretty much swap, and I'm going to get N equals 14 over sine 30 degrees. And that's going to be, when I plug it into my calculator, 28, I believe. 14 times 2. Okay, and then how do I find M? Well, I'm going to do the same thing. I'm just going to set up another trig identity. So let's do one that has adjacent with opposite. That's TOA. So tan theta equals opposite over adjacent. And so I'm going to put tan of 30 degrees equals 14 over M. Once again, I can see that I'm going to switch these the same way I did up there, these two right here. If I multiply by M and divide by tan 30, I'm going to end up getting M equals 14 over tan 30 degrees. Okay, and that means that M is equal to, after I put it in my calculator, I'll get 14 square roots of 3. All right. You guys are welcome to skip forward whenever I'm between problems. Okay, number 5. Well, let's see. This is X. These have all been marked congruent, congruent, congruent. You could use trig here if you know that these are X and X, and this is a right angle. That means these two have to be the same, and these two have to be the same. And the only option for that is that this is a 45, 45, 90. Or you could go to Pythagorean's theorem. That's probably my favorite here on this one. And I'm going to say that x squared plus x squared equals 24 squared. So that's going to be 2x squared equals 24 squared. Okay, and then 24 when I square it, let's see, 596 or something, 24 squared equals 576. Okay, so x squared, 2x squared equals 576, divided by 2, x squared equals 576 divided by 2 is 288. And hey, I remember doing this earlier. Let's take the square root of both sides. X is going to get the square root of 144 times 2, right? 288 is 144 times 2. So that's going to be 12 when I square root that. X equals 12 square roots of 2. That sounds very familiar. I believe we did that back on number 3. Okay, moving on to number 6. Okay, so, and I'm going to try to split these. I'll just do one page per recording. This looks like it's about 15 minutes right now. So if I'm looking at 30 degrees, and I got a 24 side here, it says find the area of the figure. Now to find the area of the figure, I'm going to need base times height divided by 2. That's the area of a triangle. So this is the base, and this is the height. Okay, so it looks like I'm going to need both of these numbers here. So I'm going to use 30 and 24 to find both of these. If I haven't seen by now, with a 30, 60, 90, I'm going to find that this b is just going to be half of this 24. But that's something that if you haven't learned by now, you don't jump into that. You probably need to go ahead and set up SOHCAHTOA. And let's see, we've got a 30-degree angle, 24, that makes B the opposite, 24 is the hypotenuse, and H is the adjacent. Okay, so I'm going to set that up, and it's going to be, I want to use opposite and hypotenuse, which is sine. So sine theta equals opposite over hypotenuse. Sine of 30 equals, opposite is B, hypotenuse is 24. So multiply both sides by 24, and I'm going to get 24 sine 30 equals B. And that's going to find out that that is 12, because sine 30 is a half. But put that in your calculator, and it'll give it to you. Okay, so next, I want to set up to find H, and this has to do with adjacent. And now I could use either one, because B equals 12 is pretty easy as well. So I could use opposite and adjacent, use tangent, or adjacent hypotenuse, cosine, doesn't really matter. So cosine theta equals adjacent over hypotenuse. Cosine of 30 equals 24 over, I'm sorry, that's adjacent. Adjacent should be H over 24. If I make mistakes on this, sorry guys, I'm moving fast. Hopefully you guys catch them if I make mistakes. Multiply both sides by 24, and I'll have H equals 24 cosine 30. And then for H is equal to 24, no, sorry, this is square root of 3 over 2, so this is actually going to be 12 square roots of 3. 12 square roots of 3 when you're done. Okay, and that's the end of page 1. I'm going to go ahead and stop this recording and let you guys move on to recording 2.